Cool. So, yeah, like you said, I'm going to talk about how machine learning is used in fintech. So first, the goals. So I mostly just want to expose you guys to the opportunities in fintech. What are the machine learning applications here? Why are the business opportunities interesting? I want you to understand technically why there's a big opportunity, which is basically that the techniques that are traditionally used in finance are pretty rudimentary statistical techniques. Is that better? Yeah, okay. Are pretty rudimentary statistical techniques, and actually we can do a lot better using modern machine learning approaches. And I'm not going to really show anything technically novel, so this isn't going to be one of the cool MLMU talks when you leave with some technically novel idea. My goal is to motivate you towards some cool applications of machine learning. Okay, so first, motivating the business case. Why are we looking at fintech? So if you look at the sectors by size in the US, but also the global markets, you can see that the largest one is technology, but that's us. So we don't count ourselves as a vertical that we can go after. So a vertical that the biggest market in the world that we can go after is finance. That's the only one that's not us. And you can also see it as the highest profit margin, so they have the most cash. So it's actually basically the best market in the world, right? And the second best one, by the way, is healthcare. So here you can see that these are the non-public unicorns in the US right now from SERPs. These are, of course, the companies which are worth $1 billion or more that haven't gone public yet. And you can see that also fintech is one of the biggest ones there. So it's also one of the biggest current sort of crops of startups. And you can see that especially lending and payments companies have become really big. You guys have probably paid attention in fintech a little bit, and you've noticed companies like Stripe that have done APIs for payments, and of course all the different payment companies around the world in different countries. There's lots of different payment companies. And then lending, there's of course lots of different P2P lenders now. But outside of that, there hasn't been that much innovation. Like if you look at the drop off from those two to real estate and insurance, there isn't that much. Okay, so this is specifically for AI, same thing, but just for AI. So here, notice fintech is actually the largest, and underwriting is the largest application type. So this should also be motivating to you guys. Of the dollars invested right now in all the AI startups in the world, the most of it is invested in fintech, and the largest application is underwriting. So that should be something that you really pay attention to. So the way I break finance down is into these 5 simple sub-verticals: banking, investments, insurance, real estate, consumer financial services. So pretty much we're mostly going to focus on 3 things, because if you look at the way that the dollars have been invested so far, it's pretty much all into lending and payments, like I just showed you, right? It's all pretty much been in lending and payments. And so we don't want to focus on lending and payments. We want to, although the biggest thing is banking, which breaks down into lending and payments, we don't want to focus on lending and payments and banking. We're going to look at other stuff. And then also in investing and in insurance, we see like lots of market cap, but very little dollars invested, so those are big opportunities to go after. So business-wise, that's how we would think about it. But now we're going to get into the technical side of it. That was just motivating the business part. So has anyone heard of a term quant before? I've been asking people. No, nobody's ever heard this term quant. Maybe I see a couple nods. So a quant is a term that's usually used in finance to basically mean some guy that knows statistics, basically, right? And it's used in a bunch of different fields, like in trading or asset management or in insurance, like an actuary would sometimes be called a quant. It's basically a person who understands finance that also knows statistics. So they have statistical backgrounds, subject matter expertise. So they usually come from fields like statistics or physics, right? A lot of physicists will realize, man, there's no money in physics and I don't want to be a career academics. What am I supposed to do? And then they get lured into a bank or a hedge fund or whatever. So that's like what a quant is. Or sometimes they can be economists or what have you that have a good statistical background. Some econ PhDs or finance PhDs actually have pretty good statistical backgrounds. And they have really deep financial expertise. They go in straight out of school, or they do PhDs in a technical finance field, so they really understand finance in detail, right? Whereas ML engineers, they also have strong statistical backgrounds. Anyone who does modern theoretical ML has good statistical background and mathematical background, and they understand probability and optimization and lots of other good stuff. But they can also build large-scale production models. They know engineering. They might know a specific vertical of modern machine learning, like natural language processing or computer vision, or they might have a specialty in deep learning, or they might have a specialty in sort of optimization of a huge number of parameters. So, you know, you have specializations which are different, and they're all very practically motivated based on specific types of applications. So when you take an ML engineer and drop them into finance, you can see you're going to get something pretty different because they have a different approach, different skill set. So what do we bring to the table? So more and better features, right? Like we'll see later on, a lot of these models are the same. So I'm going to rip through a lot of the technical content pretty quickly because it's all pretty simple linear model stuff. But we might throw a massive number of features at it because we're going to do a lot of, you know, scraping of data and information extraction and so on to get different features. So again, like we're going to do tons of different hacks to get more data. We're not just going to take what we have. Like a quant type person is not really having any engineering skills to be able to envision ideas to go out and get new data. So they're very limited with the data sets they work with. And we're going to use more different models and tools. Basically, machine learning is kind of I think of it as a strict superset of the you know, statistical toolkit, right? We're going to do all the same kind of stuff. You know, what a machine learning person is going to use as a baseline model is just going to be a standard statistical model anyways, right? You're just going to start with the same type of thing. And we're going to have better results. I think, you know, if you look at how a company like Google or Facebook or Cessnam or whatever, you know, uses like a ranker, right? How do they put a ranker into production? It's very rigorous, right? There's banded tests, there's a whole bunch of different tests, there's different teams that check quality in different ways, and I actually think it's far more rigorous than what you see in the finance domain when you talk about people testing their models and making sure they're robust and test over different kinds of data, and then also monitoring them in production. So I wrote a blog post with more detail if you're curious about this thing, about the history of quants and what's different about quants versus modern machine learning approach. But that's sort of like at the core of this whole fintech, you know, machine learning and fintech theme that I'm telling you about today. Okay, so let's look at the approach in different applications and how it's interesting. So first in banking, we'll look at compliance. This comes from a new company that we're doing in a R&D center that I have. It's got a lot of traction. That's the information on the right. The reason we care about the problem is because people are getting fired. And basically, you know, here it's a risk screening problem. So you have like a person who's trying to sign up for a bank account, and I want to make sure that they're not too risky. So first, you know, I might have some limited amount of information about your identity, and I have a ton of information in the outside world that's both structured and unstructured, and I need to do effectively an ID match, right? So that's one machine learning problem. And then I want to understand for all the content that I think I have about you, what kind of topics does it have? Does it have information about the source of your wealth, and so on and so forth? I'm trying to extract information about it. And then I want to sort the end results based on what we think is relevant for compliance. In other words, what's relevant to somebody that's trying to decide whether or not the bank should accept your risk. So, you know, there's complicated issues here with name variations, nicknames, et cetera. Names in different languages also complicate things. It's hard to get good training and test data. That's a big problem. Data is sparse a lot of times in what you're looking at. You might only have, like, it's very terrible if you only have the name and you have no other fields, right? That's very hard, especially for common names. I mean, there's no magic that you can do there. If you don't have any other fields, it's just, you can't do anything. So you can use human annotations, build annotator teams. That's one thing that we're doing is build, sort of have a data engineer manage a team of annotators and maybe even build out some tools to help to more rapidly annotate, like little active learning tools. I've built those in my past companies. Those can be helpful. And then mining, big graphs of information that exists online. For badging is basically a classification problem. It's pretty much topic classification, but we run into more general cases, like, for example, legal issues. Sentiment, meaning, like, is this adverse news or bad kind of news about the person generally? Source of wealth, that's an example like I just mentioned, where did this person get their money? So this is a classifier of a much more complicated concept. Usually that'll be a tree of classifiers where you have multiple different classifiers that are classifying different things, and then another one that takes those as input and tries to solve the end problem, for example, source of wealth. Where that gets really interesting is extracting detailed information that comes together with that badge. For example, source of wealth. Now show me some numbers connected to it, or other structured information that relates to that event. So explicitly handling the numbers and the different types of events and having different templates, right? And so this was one that we tackled in my last company. And again, the way you deal with it is usually hierarchically. First, you hit it with a classifier that identifies the content type, or that identifies the event type, and then you hit it with another set of classifiers that do the information extraction based on the type that you've identified it as. And then ranking, the simple baseline is, of course, just a sum of the badges that you find. You can have some weighting for those or whatever, but that's going to be the simplest possible baseline. We think we'll probably end up with a linear model based on other previous models. A lot of times for this type of ranker, people will just use a logistic, or they'll use some type of really simple tree model. For example, that's what we used in my last company, Prismatic. That's the kind of models that Facebook uses. It's a very common model in the learning to rank setup. So we'll probably end up with something like that. Other problems, different languages is obviously a big one. So we have to go step by step rolling out classifiers for each individual language. That's one thing which is much more complicated with NLP versus simple IR kind of stuff, is that with the IR kind of stuff, you don't really have to do as much specialization for all the different languages, in the sense of having a completely different set of classifiers for every language, like you do when you take this approach. And then, being able to get training data across multiple different banks and build a meta model, right? So if I'm training my model about what identifies a person as risky across many different banks, then I have a different model locally trained within each bank, because I can't let the data outside the bank that's private with respect to something that the bank knows about making you risky. So if they have a bunch of analysts saying, yes, this person's risky, no, this person's risky, right, and they're making decisions inside the bank, we're training models that help, obviously, to rank the content better on what's risky content about a person. So how do we let that model outside the bank, even though we can't let the underlying data outside the bank? Well, we can just export the model parameters, but then how do you blend them all together? And so that's like sort of this distributed learning problem. Okay, so next is loan underwriting. So simply put, loan underwriting is, how do I want to underwrite this risk? Or sorry, do I want to underwrite this risk? How much of it do I want? And at what interest rate? So it's like, if you come to me for a loan, number one, I might not want to give you a loan because I might not believe you're going to pay me back. Number two, you might want to get a loan for a $10 million home, and I might not think that it's a very good idea to loan you much of that money, right? Let alone 10 million of it. And then I'm going to have some reasonable interest rate that I'm going to set. So quickly going through like the flow of lending, I'm not going to dwell on it very long, but basically, you have a risk appetite, so you have a risk along certain dimensions. Maybe I only want a certain amount of risk exposure to a particular country or a particular geographic area, because that's going to expose me to like catastrophe risk for hurricanes, for example. I don't want to lend all my money into this one part of southern Florida where everybody's going to go bankrupt at once because of hurricane risk. So you need to think about those kind of things. You do your credit analysis, you collect all the data about the customer, you decide whether or not you're going to lend to them and how much, and what the interest rate should be, and then of course you have all the administrative work. So basically for interest rates, we're not going to go into how you set them exactly, but just so you guys understand, there's some underlying like machine learning / statistical problems, and then it goes into a financial model. And the financial model is complicated because, number one, you have this risk-based pricing that we're going to go into, which is really the ML setup. And then number two, you have what the market will bear. So, what if everybody else is willing to lend to this person at an unfairly low price? And our model says, no, this person is way riskier than that. I'm not willing to lend to them at that price. Well, we can offer them this other price, but they're not going to take it, obviously. They're going to take the lower interest rate. So there's this what the market will bear. There's our desire to maximize profit. If maybe we would price you at one price based on risk, but the market will actually bear a higher price. Maybe you would bear 2x the price. So then maybe we would try to charge closer to that because we're motivated to maximize profit as a business. And then the last one is regulation. There's a lot of different regulations governing this kind of stuff, to avoid, nasty problems like racist lending and all this kind of stuff. So there's tons of regulation around this that sets you up to be able to have certain limits around how you can bucket people into different categories and decide the interest rates. So we're not going to go into the details of all that because it's mostly non-technical stuff. So instead, we're going to look at expected loss, this idea of evaluating the risk of the loan, right? So basically, if you've sustained a default, so the person decides not to pay their loan or they can't pay their loan, how much of it are they going to default on? The entire thing or only some of it? The probability of default, of course, what's the likelihood that they're going to default? And then the exposure, what's our total dollars that we loaned to the person that we could lose? Sorry, I went the wrong direction. So here again, we're going to look at the Quant approach versus the ML approach. You can see kind of the difference. It's pretty straightforward. So in the Quant approach, you usually use a logistic. You do it with less than 50 features. These are the kind of features you use. It's pretty simple. In the US, we have this thing called FICO score. So people use FICO score for credit history. You use salary, you use employment history. So it's pretty static data. It doesn't change very often. And it's a pretty small number of parameters. And they just stick them into a logistic. For machine learning driven underwriting, we're going to use thousands or millions of different parameters. We're going to get financial data and we're going to get data that we can find online. We might even use other data if we can get data from their mobile device or so on and so forth. And then we're going to incorporate data that changes very frequently. Like we might actually featureize all your payment history data, for example. Whereas a credit score is going to summarize that in a pretty naive summary statistic, and you're not going to have any chance to, like that logistic, right? It sees the FICO score. It doesn't see any underlying payment history, so it has no way to learn from any of that information. So basically, this is a super important point, and one of the main points is that in the traditional quant approach, you sort of hand roll up these extremely high level features. Whereas in the modern machine learning approach, we're fine with more engineering and we understand how to optimize without overfitting really well. So we're not afraid to have thousands of parameters or millions of parameters from tons of data from you online and tons of your behavioral data from finance. We don't need to just have like one score that summarizes your credit. So that's the big difference. So some leapfrogging examples. Where's this happening already? So underwriting as a service, there's a company called Zest Finance that you can check out that actually just has a machine learning service for other lenders to use their underwriting. P2P lenders, lendingclub, Prosper, all the big P2P lenders, have machine learning models for different parts of their markets. For the underbanked, for people where you don't have good credit history, so this is an issue where you're kind of forced into this approach because you don't have their credit history. In that case, LendUp is an interesting company for you to look at. And then in emerging markets, e-commerce is huge in China. It's the biggest market, which we'll look at in a second. But basically, there's no real credit scoring, consumer credit scoring like there is in the US or in Europe. And so this idea of bootstrapping on top of the Chinese e-com companies who are actually the ones who have the majority of the payment data has become a very interesting theme in Chinese lending. And then for SMB lending, I'm going to talk about a Mexican small business lender. Again, the same case where they wanted to lend to businesses, but the businesses don't really have any accounting systems, so they don't really have any ways to report any accounting numbers, which is kind of the core of how you lend to a business. So we'll talk about that case too. So let's talk about the Mexican one first. So again, no accounting data at all. So this is a really cool startup that I saw last year. First thing they did was ship software, right? So they go and they sign up these Mexican companies, small businesses, for accounting software, which they give to them for free. And they're like, we want to give you loans. You got to use this software for a little bit. And once you start using it, and it's free, then we'll start giving you loans. So I thought that was a really genius idea for bootstrapping it. And then, they collect this balance sheet info. So these are the kind of data they look at, right? It's like, how much money does the company have already? How leveraged is it? How much debt does it have? How much cash does it have? Basically, how easy is it for these guys to pay me back? Same thing on the income statement is like, are they growing a lot? Do they have good margins? So like if all of a sudden they have to sell their product or their service for less money, is it still going to be able to pay me back? So you're evaluating a lot of this kind of risk. Again, how much does their cash flow cover the debts that they have to service? And so, they take all that data, they put it together, they underwrite, but they couldn't have underwritten without the software, right? So that's the key thing there. In this case, for mobile lending, so this is happening a lot in emerging markets. So it's happening a lot in Africa, it's happening in South America, and we've been also seeing it happening in a bunch of parts of Asia as well. Basically, the deal here is like, again, you don't have any data, but you have mobile data. So they'll have data about how they pay their mobile plan, or oftentimes they'll have prepaid plans where when somebody's done using the minutes on their last plan, they have to, call in and sort of re-up, right? And so they might have an idea of automatically re-upping on a loan basis based on people's previous behavior of re-upping and paying for it like very regularly, right? So there's a bunch of different approaches around this. Basically, I think this is, again, very interesting because you can see it's a case where it's a totally different set of data. It's just coming off your mobile phones and your payments for your mobile phone account. And people are, again, underwriting off this, right? And then the third set of data is this Chinese e-com lending thing I mentioned. So here, again, it's a case where it's like, how do you do consumer lending at scale in China? It's now a $500 billion e-com market with 500 million people. It's huge. It's the biggest e-com market in the world, so it has the most activity in the world and the most data to underwrite on top of Alibaba, which is the biggest one in the market, I think 80% or something. They have Alipay, which is a huge, huge, huge payment company that's bigger than PayPal or Stripe or anything. It's massive. And they obviously have a massive amount of payments data. So, Alibaba is really positioned to be the top Chinese consumer lender. And again, they would do this leapfrogging model where they're building these underwriting models on top of a massive amount of consumer behavior data from e-commerce and from payments. So next, let's talk about insurance underwriting. Okay, so here, the technical goals are to estimate the likelihood and frequency of an insured event, right? And then we want to see what the loss is going to be given that the event occurred. And then we want to come up with an amount of coverage that we would give them and a premium we'd charge and like how we want to build our portfolio of risks. Again, you can see it's the same thing as lending, exactly the same steps. It's, underwriting insurance and underwriting lending are very, very similar. More or less, they're the same from the perspective of a machine learning person. So the generic insurance model, walking you through here. So you have a population of risks that you're willing to take, a portfolio of risks you're willing to take out of the overall population. Oh, I forget I have an awesome laser pointer. And then you have a frequency model, what's the probability of a given event. And then you have a severity model, what's the probability of a loss given that an event happens. You have a loss distribution. And from that, you come up with your model, your Excel model, which is all the accounting that turns that into a price or a premium that you charge somebody, right? So you end up with something like this. So you work with like an actuary, right? An actuary, again, is a person who understands stats, but they're a subject matter expert in finance. And that's a person who's making a table like this to turn the output of these two models, or these three, into a price. Right? But these three models, we can come up with these in a much more sophisticated ways. We don't have to have the actuary come up with it in traditional ways. So that's what we're going to talk about. Basically, this is just taking numbers, like sort of tail distribution numbers, and putting them together with a bunch of different accounting parameters, like you can see sort of like how much profit are we trying to charge as a part of the premium, what's our fixed expenses, stuff that we have to pay for regardless, what's our tax, there's all a bunch of accounting stuff. That's all this is. And so we have an insured entity, which is a company. We have an insured event, which is a security breach in the case that we're looking at, like the Yahoo disaster that we all just saw. And then they could have a stock drop, or they could have a credit rating change, et cetera. And those are the type of events that this company is trying to insure against. Okay. So the baseline model, you can see here we have, Okay, cool. So we have this inflated Poisson that we assume, And the reason we do that is because if I get a collection of breaches from public companies over the past 5 years, we have to assume that that is an incomplete collection of breaches, right? It's not like these breaches are all known to them. So we only know that, you know, a breach has been reported. We don't know much about how many of them occurred. So somehow we have to have padding for that, and we have to account for that. And so that's why we use this. And then for the loss model and the loss distribution, we're just using gamma distributions, right? So this is, again, the baseline. This is sort of the very standard approach, right? Is you're just fitting these distributions to the data that you have and composing those. This is what the data pipeline looks like. So you can see we're getting breach data from structured and unstructured sources. There's a bunch of these open databases that you can get, and then there's a bunch of different databases that the governments have, and then there's news databases, et cetera. We aggregate all that stuff, and then we, of course, have a pipeline for featurizing all of it. So we come out with kind of the best breach database in the world for learning these models. And so, you know, what are the next steps? Actually, I didn't explain this. One thing I meant to say, over here, what we started with for the baseline was just one industry code. So that was the only feature initially, so starting with a single feature model. So the next steps are obviously to enhance that a lot based on all the other data we're gathering about companies. And then I think, let's see, I think the only other thing, again, like using pretty standard approaches. Initially, you don't need to go beyond like using GLMs. Anything in GLM toolkit is going to be probably cool for this problem. It's really about this issue where you can't get enough breach data and you can't really featurize it well enough. And so if you're stuck with these, you know, this kind of approach, like it's really limited, right? You just have this one feature and you have some really crude assumptions about the distribution. And so being able to use a model like this with the ability to use it on top of a larger set of features is sort of the initial goal, right? We're not trying to target anything fancier than that. But a couple of complicated things to think about. One is correlated risk. You know, what happens if you know, AWS, if there's a breach on AWS somehow, and a whole bunch of companies, you know, have the same issue, right? That's a correlated failure that a lot of people worry about. You know, what happens then? So there's concerns about correlated risk. Non-stationarity is another one. You know, we have this data from the past 4 years. How do we know what that says about the future? We don't know that much, right? Because this stuff's changing a lot, and so it's very unlikely that's a stationary distribution of these events over the past 4 years. So that also complicates things a lot. And then there's uncertainty right around the model. Like there's uncertainty because we have a small amount of data. There's uncertainty about a lot of the assumptions in the model. And then there's uncertainty about the uncertainty itself because we're not even really aware of a lot of the limitations of modeling this problem because it's so new and the data is so sparse, right? But the good news is once we get this kind of approach right, we can apply it to tons of different other types of risks. So these are some examples. Even things like war or, you know, political risk. There's a lot of applications. Investing, okay. Has anyone ever heard of factor models by chance or looked at finance or investing at all? No? Okay, I'll go, it's pretty simple. So first we'll go through CAPM and beta, that's the capital asset pricing model. Then we'll go through the FAMA French 3-factor model, then into multi-factor models and machine learning applied in investing. So CAPM, capital asset pricing model. Okay, let's go through this. So it's basically just a linear model, right, of a single parameter, which is beta. It's pretty straightforward. So you have this sort of risk-free rate of return. You have beta, which is the sensitivity of this asset return relative to the market return. And then you have the expected return of the market and the expected return of the asset. So basically, it's pretty straightforward, right? It's really saying that we have a linear model, and the main thing we're looking at is the sensitivity of this one security against the market, right? That's pretty much really all it is. And then, you know, people came up with this. That was like the first idea, right, in finance was, so the very first idea is a simple linear model of one parameter, where the one parameter is this idea of risk-adjusted return relative to the market, which is beta. It's a core idea in finance. You can read more about it. Second idea that was like pretty significant was this Fama-French three-factor model. I'm basically just stealing a few slides here from this dude because I was too lazy to reinvent the wheel. So if you want to check out more about this stuff, you can see it there. Basically, this simple analysis only works if you make the very simplifying assumption that they do in finance sometimes, where there's no arbitrage rule, right? There's no anomalies, there's no arbitrage. The only thing that there is this efficient frontier based on risk-adjusted return. So you can't actually get any what's called alpha return or outsized risk-adjusted return. That doesn't actually exist. The only thing which exists is getting more return for taking on more risk, where risk is defined as basically volatility or change in price. So that's like sort of this core idea of finance. The problem is it isn't true. There's tons of anomalies and biases in the data. And so this really, and it makes sense, of course, you couldn't model something as complicated as the stock market with a one parameter linear model. That doesn't make any sense. So obviously the assumption doesn't really hold true in a very base way when you just think about it. So, instead you need to sort of expand on this multi-factor model, right? You have to capture other elements. So these guys came up with the three-factor model. They basically tried to distinguish somehow between strong firms and weak firms using these different collections of features. So that's pretty much what they did. So here are the three features. So what's the excess return of this stock versus the global portfolio? What's the premium for small businesses, right? So a portfolio of small stocks versus a portfolio of large stocks. And then what's the difference between high book to market stocks and low book to market stocks? So again, we're basically bucketing them these ways, right? So if it's high book to market and low earnings, then it's weak. If it's high earnings and low book to market, then it's strong. And then again, it's just a linear regression. That's it. Really simple. And then you're just estimating the factor for each coefficient. Okay. So eventually, basically, with these multi-factor models, you just have GLMs, right? So if the evolution here was like the single CAPM with the beta, the single parameter model, this Fama-French three-factor, basically three-parameter model, and then now there's this general idea of multi-factor models, and it's just like GLMs, right? So again, this is just regular machine learning, and it's really good and straightforward stuff for people in machine learning to get into. And there's tons of open problems here, and those really are the types of models that are used right now as state of the art. So it's great stuff to dive into. Real estate. This is really a couple of cool problems. So the first one is OpenDoor. This is a startup started by one of the guys who worked with me in my last company. Their proposition is pretty simple. It's sort of a pain in the butt to sell your home right now. You have to do stuff to it to get it fixed up. You have to put it on the market, work with a broker, get different bids. Sometimes people drop out of the bids. You have to wait. You can't really guarantee anything about when you're going to sell it once you put it on the market. There's all these different pain points which they're highlighting here in some of their marketing. And the core of what they do is really interesting as a business model in terms of a machine learning application and how it unlocks a whole market opportunity. So they first predict the price of the home. And because they're willing to depend on their prediction of the price, they're just willing to offer that price, right? So they actually will just tell the person what they'll offer them immediately. And they'll buy the house without even seeing the house. They just know based on the spec and the neighborhood and all the other things what a fair enough price is for it. And on average, it's good enough that they're willing to just do it. And I think, of course, they probably have some small discount on it because they're just taking it immediately and providing instant liquidity. So it provides this market liquidity because you can just buy right away. It enables you to buy right away. And then they have a nice marketplace model because once they have a house, they set it up in this cool way where people can just come and see it. And there's a whole nice user experience around how you go to the house and check out the house. So that completes the loop and it gets them to, have a full market, a two-sided marketplace. So that's really cool because again, the core is like it's unlocked with the machine learning, because without the machine learning, you couldn't have that ability to trust a price and just offer a price instantly without having any humans in the loop. And that's what unlocks that whole opportunity. And that business is growing ultra fast. It's worth a ton of money. If you go and read about them, they're really doing extremely well. So I think that's a huge validation of how interesting it can be when you do one of these machine learning models really, really well for a core finance problem. It's not just necessarily incremental gains, on revenue from lending or something. You can totally do business models because of it. Another one, this is just one that I made up that I've personally thought was pretty interesting, is like if you use computer vision to featureize satellite imagery, and then you sort of joined it together with historical real estate price data. And then you identified investment opportunities, real estate investment opportunities. So you're basically finding sort of the most appealing beachfront property that has nearby really nice houses or whatever that's most underpriced relative to its area, as opposed to its peers. So things like that. That's another really neat. So you can take the same kinds of base models that I just showed you and get into really neat stuff when you start to featureize unorthodox data sources like imagery. And there's lots of other examples like this in other finance areas. So I'll give you guys a couple companies if you want to look them up. One's called Orbital Insights, and they basically are featureizing space data and selling it to hedge funds. There's another company in Prague called SpaceNo that does basically the same thing. And then there's a company called Descartes Labs, which uses satellite imagery joined together with agriculture industry to predict crop yields. That one's pretty interesting. And there's a company called Cape Analytics. Cape Analytics uses actually lower level like drone imagery, Cessna imagery of cities to help insurance companies underwrite risk and be able to run claims on risk. So basically, you don't have to send people out to properties because you can just look at it from overhead and see what's going on with the roof, what's going on in the pool, et cetera. You don't have to send a building inspector out to look at this stuff because if you have high enough resolution imagery, which you get from Cessnas, you can just do it all automatically. So there's lots of other cool applications that are really interesting that use imagery data, not just satellite imagery, but also drone imagery. So if you're interested in computer vision applications, I think a lot of the computer vision applications that are really neat, especially with aerial imagery, will end up having a fintech focus. So something for you to consider. So in summary, it's mostly linear models with pretty few features. Right? Like I showed you in the lending examples, it's like FICO score, how much money do you make every year? No really clever featureizing of past behavioral data or something like that, for example. I've worked on, with Prismatic, we had one of the best personalized re-ranking systems in the world, and we worked a lot with other people at Facebook and Google and other places to develop it and talk about it. And like the way that we featureized historical behavior of people, it was incredibly sophisticated, and the fact that they use, and it's the most valuable features, obviously, and the fact that they use effectively none of that, and it's just rolled up in a very crude way into the FICO score, is obviously, telling of the fact that there's a huge opportunity on the feature side, right? Even without getting into any fancier machine learning. Just purely on the engineering and the feature expansion side, you can basically just set up a logistic and do a much better job. And then, of course, you can go beyond these same basic linear models. So I think, as a machine learning person, you have an opportunity to set up a baseline which is already more sophisticated than what's being done today, by just using a logistic within, with a broader set of features. And then you can start to iterate from there, going to more sophisticated models that might capture some of the dependencies better and so on. And I think that really the future of this stuff will all be driven by machine learning research teams. And then we work on this stuff. That's the last thing quickly, like what do I do and what is this shit? So I run this thing called CAI. We have an incubator team in Prague and in Bratislava right now, soon probably in Brno also. And we basically work on a lot of these kind of fintech problems. And then the other big area that we're going into next is healthcare. So soon we'll be starting to talk about some of the same types of problems, but more in pharma and drug discovery and domains like that. So that's me, that's the fintech spiel. So what questions do you guys have?
Thank you very much.
Yes.
And now we have a space for Q&A. So if you have, guys, some questions, now it's time for you. So here's.
Do you know if some companies use also language processing and scrape for some news and do decisions by using these news articles and stuff like this?
You mean like in financial trading, or?
For example, or even if for the stuff you talk about.
Yeah, definitely. So for example, in trading, definitely people do. And there's even companies that do this. For example, there's a company called Data Miner, Data M-I-N-R, that sells stuff for this. But basically just straightforward event detection and all that kind of stuff, people definitely do and use that data. There's very little good academic research on some of those, on new problems like that, but it's used in industry by hedge funds and stuff. And then of course all that kind of stuff is used really heavily in the risk screening problems that I showed earlier, like in banks and stuff. You know, when you need to understand somebody's identity and the risk of their identity, then you get into a ton of NLP problems. And then I think generally, when I was showing the insurance stuff, right, so there's a limited amount of good structured data about those security breaches. And not just, you know, the characteristics of the breaches, but also just the data about the breaches themselves. They're not capturing all, you know, stuff. And, you know, we talked to, I'm not going to name names or anything, but we talked to one of the groups that claims to have the best data set in the world of these security breaches. And we asked them why for 2 years there was half as many breaches. Said that seems pretty weird, right? Turns out because they didn't have enough staff and they were manually curating the breaches. So that doesn't sound like a great data set, right? When the number of breaches all of a sudden changes by half, you know, during a couple of years. So, you know, what does that tell you? It tells you that you can't really trust this structured data set in terms of its breadth at all. So how are you going to get that data? Well, now you have to go out to the news, you have to go out to SEC filings, and it's basically all NLP, and in particular information extraction problems. So I think for this idea of extracting events from unstructured content and then being able to assure against those events, like many of the other branches of insurance or risk niches that I showed can also be done by the same methodology. You can bootstrap them on unstructured data. So I think NLP in unstructured data that's open is one of the most fertile fields, right, for bootstrapping these machine learning things, you know. So this is a case where, as a startup, I'm pretty confident that we either have or will have within the next few months the best, you know, breach data set in the world, and it's taken us a while to build it, but basically that's pretty awesome, you know, because you have all these insurance companies that have a ton of data that they claim is proprietary, and a bunch of other big companies that claim to have all this proprietary data, but actually they have a very limited picture. And by applying good NLP on open data, you can actually bootstrap yourself into a better situation. So I think NLP and open data is one of the most democratizing things for bootstrapping these machine learning startups, because you end up being able to get a ton of training and test data, right? And also you have, like, you know, semi-supervised approaches and so on, where you can incrementally bootstrap into really good, clean data. You can build a little active learning interface and stuff, and you can do all these cool hacks using these modern techniques to bootstrap training data. So for me, that's really exciting on almost any of these problems, but in particular, anyone where you have like a structured event and you have like a crappy amount of that event data, and you need to get more. Yeah.
Thanks.
Mm-hmm.
Okay, any other questions?
Actually, I have a question not on this topic, but
Yes.
on Prismatic.
Yes.
What is the reason why why it failed?
Good question. I think that it's weird. There was an era of the internet where I think a bunch of us thought that there would become more hybrid models than pure social, right? There was this transition from, the very early days of sort of the web portal stuff, the Yahoo stuff, and so on, the straight-up portal. And then there was the PHP-BB era. I don't know if any of you guys remember that era. I think a lot of younger people, you guys might not know what's up with the PHP-BB era. It's basically sort of like a IRC for the web sort of forum thing. It's pretty weird. And then you had like the communities like Reddit and stuff, and then proper social networks, right? And when we started Prismatic, it was around like early 2012. When we first started on it. And there was other people starting to play with these hybrid models too that were like partially social or aggregating social or trying to be like a next generation of RSS or whatever. And RSS readers were dying, right? And the pure news reader thing was dying, and Google News was kind of dwindling as well. And everything just went all social, and we were just kind of wrong, and I think everybody else in that space was wrong, and the social just won. Everything went to Facebook and Twitter and stuff, and the social model ended up being the winning model. And the pure reader type model or hybrid model really didn't work. So if you look at us, we ended up in the same position as, Zeit. There was like a whole bunch of other ones that were really smaller. There was, what's the one that LinkedIn acquired? I'm spacing on the name of it now, but there was a pure news reader which LinkedIn also acquired long before they acquired Prismatic. They acquired Prismatic for the tech, but they acquired them just for like the reader app and mobile team that built all the mobile reader stuff into LinkedIn, right? Because you see even now, like all of you, if you go onto LinkedIn, you get the LinkedIn feed, which has all these news articles. And LinkedIn acquired Prismatic for using our natural language processing and feed ranking and all that kind of stuff for the LinkedIn feed. So what ended up happening is all these social networks basically just won the content wars, right? So like almost all distribution now that modern media companies care about is social, because like they've already done search, they've already done SEO, they know about that channel, but the social channel is as big or even bigger for a lot of these pubs now. So everything just went there, and we ended up really stuck at the like million user range, right? And I think a lot of the other things ended up also similar. And Flipboard, which is the last company that's still out there, is super highly valued and has raised a ton of money. And they also just, they can't retain a very high number of active users. It's turned out that the social sort of UX model has been the only model that's retained a very large number of active users in modern media. So I think we just acknowledged that we had pivoted to ad tech, and we could either like grow a big ad tech company or just sell it to LinkedIn. None of us were really excited about ad tech, so the choice was pretty clear, So we ended up doing that in the winter of 2015. But it's an important lesson because we fought it for, I think, too long. And I think you just have to acknowledge, like, when you're wrong and the market is just like not there, you just have to stop earlier. And I think we were trying to force it, even though the signs were more clear, because the other ones were also failing or selling off. And we could see our numbers stalling out, and we were pushing it and doing feature tweaks. And it's like, you should think of a product as an optimization problem, right? And like, if you're doing these small tweaks and nothing's really happening, you might not even be in the right region of the space at all. So I think that was the case with us. So we're turning these knobs and taking these small steps, but the global optimum was like way the fuck over there, as a social network, and eventually we were like, okay, that's like too far away. So that's the Prismatic story. All right, what else do we have?
Yeah, thanks for excellent talk. Well, we see robots searching for PHP, BB, vulnerable forms all the time in our search engine logs, so they are still active.
Yes,
but
still out there.
My question is, you said that most of the fintech banks use simple linear models. And the reason could be that actually human can see what happened in the model. maybe when you, I don't know, offer some kind of more complicated model to the banker, and the expert cannot see what's in there, maybe then they don't trust it, or so
it's a great point. And actually you can see that in both the industries that we focus on, which are finance and healthcare and medicine and life sciences, these are very regulated. Right, and so these models actually are subject to specific types of regulation, and in banking they call it model validation. So there's like an audit process for models. So you're absolutely right that does put constraints on what you can and should do. But really, it's not limiting this kinds of things that we should be able to do. You just have to be able to document it and reason about it, right? So let's walk through a concrete example. So let's say that I said, I'm going to use your social media profile and I'm going to featureize that for this lending model, right? And so now my regulator comes in and wants to audit that and is like, what's going on with all this social media data, right? So I might have actually, let's say that I have millions of features, right? Because I've decided to represent one of the things that, I've decided to blow it out and have it be individual features. So if I do that, now you might say, well, how am I going to explain all the these millions of features? This is really weird. But actually, these people can reason about it if you can explain it in the right way by saying I have these families of features, right? So you can see here that what I've done is I've mapped all the text that this person has shared. I've mapped it into some like space of terms, right? And each one of these is a feature. Right? So you don't need to worry about the fact that there's, what's going on with each one of these. You only need to realize that there's this family of features which correspond to, they correspond to the text that the person has in their profile. So I think if you can explain, the families of features or the groupings of features in the way that you've generated those, and then you can of course drill down and peer into the values of any of those individual things. But people can reason about that model. So one model that's common where you would be worried that they couldn't audit is this very highly parametric, like logistic sort of a setup, right? Which is very common. But I think that one you can get by in the grouping way. The other one is like if you wanted to use deep learning, right? And you're like, oh, now what do you do? And even there's starting to be different things, like local interpretability is one idea. I can show you why for any one example. There's new approaches that are thinking about global interpretability or other forms of interpretability. So people are thinking about interpretability even for the most complicated models. But basically, I think actually we're at an advantage here, big time, over the traditional approaches, because when you are an engineer and a computer science person, instead of just a statistical person, you think about doing a ton of other shit that they wouldn't think about. Like, I can auto-generate all my documentation for these models, right? Well, I wouldn't write it. These guys write it. They have there's dudes that write the stuff in a big doc, and then there's another group where there's a bunch of people who audit the doc within the bank, and then they flip it outside to an accounting firm that audits it again, right? And so we should be automating and auto-generating a lot of that stuff as a record, right? So there's a lot of stuff where we, I think, have a really big advantage. Even though the model might be more complicated, it might not actually create any more work. You might actually have less work to deal with the auditing of it if you just have to set it up once and take more of an engineering and an abstract approach, right, that a CS person would think about. And you just don't see that happening in finance today. It's all done with bodies. None of it is really thought through as an engineering problem. So I think it's not a limiter, but it's something that you have to be very aware of and proceed with carefully. Right? And it is like a nice barrier to entry for some of these businesses, because a lot of purely technical people will shy away from that, because they're like, that's a pain in the ass. I don't want to worry about that. I would rather just target ads, because if I give lift, we make more money. It's really simple, and nobody can fuck with me. So, all right.
Okay. Other questions?
Maybe I would just continue with this topic. So basically, are the banks and insurance companies really interested in this, or there are a lot of opportunities, but they are actually not interested in it, and they have their old proven models and don't want to use any of this new stuff? So when you come to them and told them, I have pretty cool model which can predict a lot of stuff, they told you, oh, sorry, we are not interested because we have our Excel sheet. So do you know?
Right. It's a good question. It's a very good question. So, and I'll give a little bit of a nuanced answer. So first of all, there's two major buckets of stuff you can do here, right? One of the buckets is what you're getting at, which is make stuff and sell it to banks and insurance companies. The other bucket is to start new financial institutions, and that's happening a lot in fintech, right? Again, like I talked about, there's the P2P lenders, payments companies, and there's payments companies like Stripe that aren't even consumer-facing. They're APIs, they're platform companies. So there's tons of options for creating finance companies instead of just selling to the big ones. So that's one thing. And where there's regulatory freedom, that's a really interesting opportunity. For example, in insurance, there's more regulatory freedom. In some countries in Asia or in the UK or Germany, there's more regulatory freedom in banking. So you actually see more of innovation in banking in Germany or in the UK or in Singapore than you do in the US. Because in the U.S. we don't give new charters right now. You can't create a new bank. So there's this whole idea of, do I want to just start a totally new thing because it's open and like I'm not that regulated and I can just start a new financial institution and there's a cool business model around it? So if so, then that's oftentimes a better option, right? Because that's actually a huge opportunity, at least from a startup standpoint. If you want to create like a giant business, then that's oftentimes a better option. So all of our insurance stuff that we do, those are all insurance companies. We don't sell any of it, so the cyber insurance stuff, that's an insurance company that underwrites insurance directly. So when we have the opportunity, we create the financial institution. We don't sell stuff to it. Because of the problems you said, right? Because there's a lot of friction. Why do I want to wait for these guys to get it and slowly educate them if I can just come in and compete against them in the market? If I think they're going to be really slow to understand it and there's not that much regulatory friction in front of me, then my obvious choice is going to be to come after them and compete in the marketplace openly. But if it's really regulated and I can't get in there, like in U.S. banking ecosystem, then like I can't really start a bank. You know, that's not allowed. And even if I could start one, I couldn't be the CEO of it. I would have to be somehow associated with it, but we would have to have a CEO that has a certain amount of banking management experience and so on. There's a bunch of stuff around it. So it makes it, you know, very hard for real like innovation in U.S. banking. And so there, you know, coming to your ultimate question, yeah, we with the compliance venture we showed earlier, which ought to be the biggest pain in the ass to sell stuff for, because it's like very, you know, core risk stuff that people are scared of because they get massive like multi-billion-dollar fines if they screw this compliance stuff up. But we see people buying our new risk software of a 6-month-old startup, right? And so why? You have to ask, why would they do that? You know, if some cases they're going to just defend their Excel spreadsheet, why would they do this for other cases? And I think this is the core, right? So there's all these problems out here where they're using these Excel sheets and simple models, and we could look at all of them and say that there's a better technical solution for each one. But that doesn't mean that it will work if you try to do it and take it into the market. So what defines the one that works and the one that doesn't work is timing. Right? So it's like, what do people want right now? You know, so look around and find it out. Like, how did we figure out to do this compliance venture? I didn't know anything about compliance. We ran an analytical process, you know, to look at the market and see what people are really talking about and what they seem to have a strong need for. So if you want to do a B2B company and sell enterprise software or sell SaaS software, you know, start with a focus on timing and what people want right now. Because, you know, you don't want to start with what's broken. One of the worst startup pitches, openers that you ever see is like X is broken, right? Who cares? You know, everything's broken. Doesn't matter. Like 99% of the stuff in the world is broken. Who cares about fixing this one right now? Right? That's what you should start the pitch with. You know, everyone wants to fix this right now because CEOs are getting fired for screwing up compliance. Well, that's a pretty big deal. Here's a couple headlines of, you know, Wells Fargo CEO stepping back. It's like, wow, that's a big deal. You know, or the cyber insurance one, like the Sony breach and stuff, right? It's like, find something where it's people really care about it a lot, and specific things that you can point to that would make somebody say, damn, like I should pay attention to that, and then that's where you want to go build models, right? Because there's so much opportunity, so there's no need to focus on ones where you're going to have to try to force it on people. And frankly, it will be that way for some stuff. If you just find an arbitrary model where you're like, oh, this could be done way better, there's no guarantees whatsoever that anyone would care about buying that from you right now just because it performs better, you know? Because there's tons of other business reasons for buying stuff, like maybe it takes a year to go through vendor diligence even to install your shit inside of a bank, right? So if they're gonna go through that, then it has to be a huge win for them. If this is really just a small thing, even if yours performs 3 times or 4 times better, if it's not enough money to run you through that complicated process, right, you see where I'm going, they may not even do it. So focus on timing, but the answer is definitely yes, there's lots of opportunities here. But you just have to be savvy about which ones you work on. Because at any given time, yeah, you can think of it as like a huge feature vector, and at any one time only some of them are going to be active, right? And so, you know, don't focus on all the inactive ones, right? Because it's not like generally if you pick an arbitrary one of these problems in a given year, it's going to work. You know, you've got to find the ones that are active.
Okay.
I would like to ask how big are these startups in Czech Republic?
How big are the ones that,
Yeah.
that I showed from me?
Mm-hmm.
The compliance one is over 20 people, has raised over $8 million and has you know, millions in annual revenue. So that one's going very fast. It's about 9 months old. So that thing's, you know, really on a rocket ship trajectory. The insurance venture, the cyber insurance venture, is much smaller. It's actually only a few people right now. And the reason why is because that one has been more in really hardcore R&D mode, like with the data gathering. With the compliance venture, we're bootstrapping it in more of that app-driven way, like I described the Mexican lender guys, right? Where you ship an app and then the app lets you gather the data and then you bootstrap that way. So Raptor was able to do that and go to market faster. Tower Street, which is the name of the cyber insurance venture, can't do that because it has to be able to price from day one, and we need an insurance partner because there's this complicated issue of like, to be an insurer, I got to have a bunch of money so that people will trust me that I'll pay the losses, right? If I come to you and like, hey, use me for your health insurance, you're like, no, dude, I have no idea if you're going to pay me if something bad happens, right? I'm like, come on, man, just don't worry about it. You're going to be like, no. So this is a really big deal, and the way you do this when you're starting one of these fledgling insurance companies is to effectively you know, rely on a big partner, you know, that is a big insurance company. And then that means they have to sign off that your pricing models are legit. So it's like pretty rigorous up front, which meant that venture has had like a very long R&D phase. So they're 2 very different companies, and it's actually pretty cool because it's illustrative of how unique each opportunity is, right? And depending on the type of product and the go-to-market strategy and how much of the data and machine learning and R&D happen before you go to market versus like the ones where you have to ship something that's really light on the R&D side first and then bootstrap. But if you put the 2 together, you know, you're looking at around 30 people. And we're going to be starting one of these each quarter and probably grow to like 80 to 100 people by next year. And then we'll be able to do, you know, 5 or so companies in parallel. So the goal will be to be able to do 12 in 3 years. So.
And how many of the staff are machine learning experts?
How many of the people? It's a good, I think in general, I mean, I'll give you the way that each team is composed, right, for each startup. So you should think of each team as about 10 people, where it's 3-3-3, machine learning, distributed systems, and front-end engineering. And then you have a designer, and then you have a PM and an engineering manager. And that's sort of like a pod. They run a startup for the first 2 years. And then it only gets a little bit bigger if the startup starts to have a ton of customers and we need to scale out and have, you know, because we have, or if it gets one really big customer that requires a massive amount of scope earlier than normal than like it does with the Raptor company, the bank company. It's pretty beefy apps and pretty beefy backends there, so less like hardcore R&D. So that's required a larger number of engineers to get through the first couple of years. But we try to only shepherd them through the first couple of years, and then we transition to full-time teams in the U.S. because they're all going after U.S. markets. Yeah.
Simple question. I would like to know what are the lowest hanging fruits in machine learning for finance? I mean, where you can make a simple or simply a machine learning model which is much more reliable than the classical statistical methods.
You're saying what are the biggest opportunities for doing that?
Yeah, and where it's easiest, where you can easily replace the...
Where it's easiest, where like the lowest hanging fruit, like okay, I got your question, okay. I think it's probably like underwriting, and customer risk issues and so on. I would say the hard area is trading. A lot of people try to do that one. It's appealing to tech folks because you have this idea of a cash machine where you never have to talk to anyone, right? And you're like, well, unfortunately, it's not that easy, right? Like the financial markets are very, very complicated to model. It's actually one of the most complicated things you can try to take on. And then also the other reason it's very complicated is because a trading system is vastly more complex beast than a predictor. Right? And people think of a predictor as a trading system. So they're like, let me predict the end day return or the end minute return. It's like, yeah, congratulations, but what do you do with that, right? You just buy it, and then what do you do, right? Like there's much more complicated stuff to figure out. So those two things stop a lot of people from success in trading. I highly recommend against messing around in trading as a machine learning person, like on your own, because it usually results in disaster. But that said, like going to a really good place, like a really good hedge fund or something could maybe be interesting. But it's a harder area to get into. It's very complicated, and there's a lot of really smart people already doing it. An easier idea is to go into areas of underwriting or areas of like dealing with risk and managing risk that people aren't really dealing with right now, right? So some of the examples that I showed earlier at the end of the insurance section, or getting into loan underwriting for areas where there's not any data, right? So that's an easy example because if I'm the Chinese e-com lender, or I'm the Mexican SMB lender, or I'm the lender that's based on mobile data, then I can easily beat the baseline because the baseline is nothing. There's no data, so you can't even use the traditional approach. And there's no way for these quant type of folks to figure out how to bootstrap that data because you need like engineering and computer science skills long before you can do any statistics. So look for these areas where there's like no data but you can bootstrap, or there's like not a lot of other really smart people already working on it, like high frequency trading or something, which I don't think is a great area. So it's like where there are not a lot of smart people, and where can you bring a lot of a win with the data stuff up front, I think, right? Because fundamentally, if you think of it like from an information theory standpoint, right, it's like, what other information do you have to bring to the table? If the simplest case is some economist is using a logistic and you're saying you're going to use a logistic and beat them, then the only way you're going to do it is if you have new information, right? Assuming that they've set it up correctly, which oftentimes they haven't. But assuming they've set it up correctly, then where's your information coming from? Like it's got to be new data sources or better ways of featurizing the data sources, and that oftentimes that's the engineering and the computer science side. So places where that is stronger, that they don't have the skills, is I think where to look. And if you looked also, the last thing I'll say about this, at the beginning I showed the ML versus Quant and how they both have stats, but the ML person has the CS and Eng, and the Quant person has the finance subject matter expertise. So go where you need less subject matter expertise and more CS and engineering, right? Okay.
Other questions?
Yeah, I wanted to ask you about your favorite topics about credit assessment and risk analysis and so on. Is it worth consider fraudsters as a separate class, or just put them into the same bucket as the people with bad judgment?
No, it should definitely be considered as a separate class. And I think that in the future, the way I see it now that I understand a lot more about this risk landscape, is that you actually have multiple classes of bad actors. So it's not just as simple as fraud, because you also have different forms of money laundering activity and so on as well that you're concerned about. So you have fraud and financial crimes. And right now they're very separate inside of like a bank, let's say, for example. The fraud group is actually reporting into this thing called the risk group normally, and you might have a chief risk officer over there. Whereas the compliance group is the one which owns financial crimes, and that's oftentimes much more like lawyers and so on. So the financial crime stuff is still this very old school rules engine oriented stuff. That's actually why we started that startup, because we saw, unlike spam or cybersecurity or fraud, you had this domain of financial crimes where there was basically no good machine learning or statistical modeling happening whatsoever. It was this crappy old rules engine things spitting out tons of false positives because, of course, they're like, you know, complete recall with no precision sort of approach, right? So I think that you'll see all that stuff merge. And I think you'll see multiple different classes of bad actors, and definitely just being bad credit or bad financially is a very, is an important one to look at, obviously. And you might not want to take someone because they have bad credit risk, but you're going to have multiple classes of people that you decide not to take, and fine-grained documentation actually that might be largely auto-generated, but you will have fine-grained documentation about why you didn't accept that person's risk. And yeah, I think it's a really big deal. And there's a lot of compliance rules about this. You know, and it's not just, you have fraud, you have financial crimes, you have bad credit risk, and then you also have notions of fairness. At least in the US, you have an issue of disparate impact and making sure that your model is not like unfairly exploiting some social injustice bias in the data. This is a really big issue that I think you'll see the internet people start to worry more about now. Like, for example, everyone's talking about the fake news crap and stuff like that. But this idea that in machine learning and consumer internet, we actually have never really thought about idea of fairness before. We just try to maximize the numbers that we're looking at, right? I mean, I see all you guys nodding that work on this shit, you know what I mean? We never have thought about this. But if you think about it, it's like, you know, this idea of disparate impact, it started in an educational system, which is like, you know, we have, you know, all white guys here in this PhD group, like, maybe we should try to do something about this. You know, this isn't representative of the broader population, this is bias, right? And if you think that these are the only smart ones, it's like, come on, that's not the issue. So how do you reverse that? And disparate impact is a way of trying to have a notion of fairness in the model, right? And so I think this idea of having a notion of fairness in the objective function will be a really big deal in lending, and I think you'll start to even see it in advertising or ranking. You know, of problems like Facebook, you know, you'll start to see these issues coming up when people are real. For example, they took race out of the ad targeting parameter, right? Race shouldn't be an ad targeting parameter. That's a crappy thing, right, if you think about it. And race is not allowed as a parameter in lending, by the way. It's taken out. But disparate impact exists because even if you take race out, I can have a latent version of race pretty easily with zip code and some other stuff. So you can't, if you tell me to take a feature out, I'm just going to replicate it with other features synthetically and have some latent version of the same feature. So you can't really take anything away if I have fine-grained data. So how do you deal with it? Well, you have to deal with it explicitly, right? And you do that with some notion of fairness. So I think when you look at the pipeline that comes at the end of lending past just good credit, bad credit, it's getting really sophisticated, and there's machine learning all throughout, right? Because you have many different problems for classifying, you know, fraud or non-fraud, different classes of financial crimes, and then notions of fairness and compliance on the end of it. So it's really cool and rich domain that goes way beyond just the good and bad credit. So highly recommend checking out all the stuff that happens at the tail end of underwriting.
Okay, we have time for the last question. Here's any. Okay, then thank you very much for a great talk.
Thanks.
Thank you very much. Okay.